All right, what's up, everybody? So, this video is intended to take you through what is correlation. So, as you know, always trying to remind you how it is that what it is we're discussing now builds on things that we've already covered. So, with correlations, we are expanding on interval ratio levels of measurement. We're going to be focusing on one specific type of correlational test called Pearson's correlation, and other correlational tests may incorporate nominal ordinal variables. However, for what we're doing in this course, we're focusing more specifically on interval and interval ratio variables. We'll also be working a little bit with the mean, a little bit with standard deviation, and then our null and research hypotheses. Of course, we're going to incorporate our degrees of freedom. There is a degrees of freedom formula for this particular test, as we've seen with our other tests. So what is correlation? A correlational test examines whether and how strongly pairs of variables are related. So we're looking for both whether they are related and if they are related, how strong that relationship is. So correlation identifies patterns of association, not causation. I want to emphasize this point because sometimes we can be a little bit confused about what it is that the results of a test may show us. We are not going to be determining through this correlational test that one variable causes the impact of on a secondary variable. All we are trying to identify with correlational tests is whether or not there is a relationship. So through this correlational test, we're going to be calculating what's called the correlation coefficient. The correlation coefficients numerically express strength and direction. We're going to get a little bit into depth on what strength and direction mean, but it describes what it is that we saw with the previous slide regarding whether there is a relationship and how strong that relationship is. Correlation always ranges between -1 and +1. And I'm sorry, that should be that correlation coefficients always range between these two values. Perfect relationships at -1 and +1 are very, very rare. So here's the formula for the Pearson's correlation coefficient. Now it may look a little bit daunting when first kind of exploring Pearson's correlation. However, if we were to just take a moment to see the different components of this formula, we've been introduced to n before. That represents sample size. We've seen this sigma symbol. This is sum of. We've seen x as a representation of a variable. The newest one that we'll be kind of being introduced to here is this y. And in this case, y just represents our second variable. So it's not to be, Greek notation or Greek letter for anything. It just represents our second variable. Knowing those pieces, then, if we look at the rest of this formula, we find that we're just doing various things with each of these variables and the sum of the scores within them. So we're taking the sum of x, multiplying it by the sum of y. We have the sum of x squared, then the sum of x squared. We do that that same process with our x variable as we would do with our y variable. There's some square rooting involved, some squaring involved. I want to emphasize, just as a reminder, we're no longer doing hand calculations, but I do want you to understand what is happening in the background of these tests that we're conducting. So this is our Pearson. This is how we would calculate our Pearson's correlation coefficient. The ranges of the correlation coefficient, as I mentioned, exist between -1 and +1. The negative and positive describes the direction of the relationship, while the numerical value itself is an expression of the strength of the relationship. So when you see a negative value, then we are talking about a negative relationship. When we see a positive value, it is a positive relationship. The numerical values then, as I mentioned, are expressions of the strength of the relationship. Notice that around the -0.1, we have a weak negative relationship. Getting closer to 0.3, we have a moderate negative relationship. 0.6 is strong. And as I mentioned, -1 is possible, though it is rare for a perfect negative relationship. And then moving in the direction of the positive values, we have weak positive, moderate, strong, and perfect.